Good afternoon and welcome to Specialist Mathematics exam preparation. We'll look at multiple choice questions. Let's have a look at question 1 from the handout. It is asking for the asymptotes of the hyperbola x minus 2 squared on 9 minus y plus 3 squared on 25 equals 1. Again, the calculator will do this question for us easily. So we need to get the calculator screen, the graph screen, and now we need to change the graph entry to equation templates. So graph entry we change to equation templates, and we wish to have a hyperbola. There are two. This one is east-west, and that's the one we wish to have. You've got to be very careful to enter those numbers properly. So we put 2 here, and then you can go tab, which brings you down. So that was 9, but here is a number squared. If I use tab again, I get there. We had plus 3, but as you see by default, it has a minus there. Therefore, we need to go minus 3 there. And then it was 25, which is 5 squared. And then we enter, and we get our hyperbola. So that's how we enter using the equation template. What we wish to find is the equations of asymptotes. So if we go to menu, analyze graph, we need to use number 9, analyze conics. And you have a number of things you can actually ask the calculator for, but we are asking for the asymptotes, and this is the equation. So we touch on the hyperbola, and now if I escape from here, I can see this is minus 5 on 3x plus 1/3, and this one is 5 on 3x minus 19 on 3, which is the answer D on our handout. We could also solve it using our skills, saying that y plus 3 is plus minus 5 on 3x minus 2. Where we get plus minus, if you press Control Book, you will see plus minus sign there. So that's a trick we could use here, and then it will give us 2 asymptotes. But clearly it's easier to actually use the asymptotes, and you can also ask for the vertices using analyze conics, and you can ask for the center. So these are some of the advantages using the graph screen for those types of questions. Next question, which of the following is an even function? And we have 5 functions here. Now, of course, you could sketch of each of those, and we know that the even function is the function which is symmetrical about the y-axis, and also the one which fulfills the rule f in minus x equals f in x. If we look at B, we have arc sine modulus x, and of course modulus x and modulus minus x is the same thing. So let's sketch arc sine modulus x on our calculator. So we'll enter doc, we insert a new problem, and we do graphs, and we'll go trigonometry, inverse sine, so it's the same as arc sine, and from our template we need to get modulus x. And if we enter, we get this graph. We can zoom in a bit, and we can see clearly that this graph is symmetrical about the y-axis. So the answer to question 2 is B. F in modulus x is always an even function and always symmetrical about the y-axis, so you could recognize that even without doing any work. Moving to question 3. Consider the circle in complex plane or argand diagram. Which of the following lines intersect the circle exactly twice? So if we try to do it by hand, it is a fair bit of work. So we'll try to do this question in the similar way as we did the poll question. So let's insert a new problem so we don't have any interference with what we were doing before. And again, we'll say let z be equal x plus y, and use I from here. And now our equation of the circle was, so we need to get modulus z coming bold, which is good, plus 3 minus 2i, and jump out of the modulus is equal to 2. So the calculator will do it for us again, and we'll square both sides. And now it is a circle, but we want the Cartesian form to see the center. So what we do, we go menu algebra and complete the square for this expression. And we complete the square both for x and for y. So this is our circle now. X plus 3 squared plus y minus 2 squared is equal to 4. You ask what it does. It does a sign. I come back to this. So I can copy this now. And if I go menu, graph entry relation, I have this circle. Now, the question on the handout is asking which of the following lines intersects the circle twice. Imaginary z equals 1 equals 0. If y is equal to 0, it intersects 1. Real z equals 1, that's our line, which of course doesn't intersect at all. And then we have some other solutions. So just to save a bit on time, I will go to the prepared file. And what I did, I choose the last answer here, part E. So again, I said, let's check what is this equation. And that, as we know, is perpendicular bisector, which is given by this straight line. And again, I copied it here to where I had the circle, and I can clearly see that this one intersects twice. The other easy way of doing it is looking at each equation. So A and B, of course, we eliminate it and pick up the points and see whether optically, visually, the perpendicular bisector would be 2 or 1 intersection. But that is a fair bit of work. But using the calculator this way, trying to get our Cartesian equation of a circle and Cartesian equation of the perpendicular bisector in part E, we can see that we have clearly 2 points of intersection here. I could see there was a question what a sign means. This sign means let z be equal. So this is control template that tells the calculator, remember my z is x plus yi, because this is general expression for the Cartesian form x. Question 4 is about the sum and product of the roots of the equation. So it says z is complex. So z to 5 plus z to 4 plus z cubed plus z squared plus z plus 1 equals 0. And we wish to find the sum and product of the roots. So of course we need to use a calculator. Let's insert a new problem, and we need a calculator. How do we get roots or zeros? We need to go menu, and we need to choose algebra, but it has to be complex algebra, and we want zeros. So it shows you C zeros, not real zeros, because it will not work. So let's go z to the power 5 plus z to the power 4 plus z cubed plus z squared plus z plus 1. If we do C zeros, we don't write equal 0, we're not solving, we just want zeros of this fifth degree polynomial, and we need to tell the calculator what the variable is. And there will be 5 zeros. By conjugate root theorem, we'll have 4 complex occurring in conjugate pairs and 1 real, -1. So now what we need to do, we just type sum, Sm, open the bracket, and we go with the arrow up here. And it tells us that the sum of the zeros, or sum of the roots, is -1. And we type product. It's fast on the computer. You might just go straight to here if you want product of C zeros without actually displaying the zeros, and it will work as well. So the sum of the zeros of this fifth degree complex polynomial is -1, and the product is -1. Notice that the coefficients are real, so the conjugate root theorem applies. Therefore, the answer to question 4 is A. Let's move to question 5, still complex number question. Z is 1 minus I to the power of n, and modulus Z equals 32. And we wish to see which one of those is true for n. Insert a new problem, and we'll be using a calculator, and we'll say 1 minus I, and we need to raise that to the power of n, and we'll now go down and we'll convert this to polar form, because it is talking about modulus, so we need this expression in polar form. So we enter 1 minus I to n, and now we go menu, this time it's number, complex number tool, convert to polar. And the calculator tells us 2 to n on 2 is the modulus, and the argument is minus n pi on 4. We only concern with the modulus because we know modulus Z is 32. So we go menu, algebra, solve, and we can grab this or retype. We know that it is equal to, I need to go back, is equal to 32, and we wish to solve for n. And the calculator is nicely solving for us. So instead of doing all that by hand, converting to polar, trying to think what it is, if you know your calculator, your CAS calculator, you can easily get those answers. So the answer to question 5 is B, n is equal to 10. One more complex number question. This time Z is K, and this is basically C pi on M is the root of the equation Z cubed equals W. given W equals 4 minus 4 root 3i, then find what are the values of K and M. So we'll try to use a calculator again. So insert problem, calculator. So this time our complex number was 4 minus 4, square root 3, jump out I, and again we wish to convert to polar. So we go number, complex number, convert to polar, and that's what the calculator tells us. So modulus is 8, so k cubed is 8. Argument is minus pi on 3, which needs to be equal to pi on n. So what we can do here, we can say solve k, solve k to the power of 3 is equal to 8, and if I press space and type n, I can do both in one go, minus, and I have pi on 3. If you have your handout, that's handy. And that is equal to pi on m. So we go pi on m. And we are solving for k and for m. So we get the answers. K is 2 and m is negative 3. So question 6 gives us the answer C. Now, solving differential equations. dy dx is e to the power 2x times 1 plus y squared, given that x is 0 when y equals 1. So we'll be using this solve with the initial condition, noticing that all the answers are given as y equals, so we'll have to obtain one of those on a calculator. Again, insert a new problem, and we wish the calculator. So we go menu, calculus, and we go to differential equation solver. I could do it here, but most of you will not have the CX tool, so you rather do it by hand. So we just type D solve, and now we go Y dashed, and we say is equal to e to the power 2x times, and we open the bracket, 1 plus y squared, close the bracket. Now we use the space and we put the initial condition, and y in 0 equals 1, and comma independent variable x comma y. So the calculator solves this differential equation for us. However, it gives 10 minus 1 minus pi on 4 is equal to this. So what we need to do, we need to solve for y. And we go comma y. It does say something else here, but we're not that concerned. So y is 10 of this expression, which is answer D on our handout. Question 8, kinematics question. The velocity v of particle at time t is given e to 3t minus 2e to t. The distance covered by p between t is 0 and t is log is 3 is closest to one of those. Whenever we deal with distance, it's really important to see the graph. So what we'll do first, we'll graph this function, which is e to the power we need to change t to x, e to the power 3x minus 2e to the power x. We might say that basically that only really applies when time, or here we need to say x is greater equal to 0. So clearly we can see that part of the graph is below the x-axis, part is above. We might change the axis a bit. So that's our graph. Now, we are after the distance, so what we can do now, we can sketch the modulus of this function, because we know that's how we actually find the distance using definite integral of the modulus. So now the calculator, remember that we have modulus of our velocity is f2. So if I go to the calculator now, I can use a definite integral and put the limits 0 to ln3. So we put the upper limit, ln3. And now we put our f2 in x, which will come bold because we define that as the modulus x, and we press Control Enter because we are after decimal answers. So question 8 has the answer B 5.1. Remember drawing and use the modulus of your velocity vt graph, and then you can safely use a definite integral. If we deal with the modulus, everything will be above the x-axis. Question 9 is about the volumes of solids of revolution. So we have 4x squared plus 9y squared is 36. The section of the curve in the first quadrant is rotated through 360 about the y-axis. So let's see how this curve looks like. So we'll try a new problem and we'll use graphs. Because we are given the relation, we might change graph entry to relation and enter 4x squared plus 9y squared is equal to 36. Just to give ourselves a picture, so we are saying now this bit is rotated about the y-axis to form the solid of revolution. So it is an ellipse which cuts the y-axis at 2. So now we can use the calculator page and we put pi first because it is volumes of revolution. So you need to remember your formula. Those ones are not written on formula booklet, and we go 0 to 2, and of course you need to rearrange your equation to make x squared appearing there, which is 36 minus 9y squared over 4, and it is dy rotation about the y-axis, which we obtain answer 12 pi. So question 9 has the answer C. Vectors question, linearly dependent, very common on the exam. We are given 3 vectors, A, B, and C, with some pronumerals, I mean one pronumeral here. We want to find the value of lambda, so those vectors are linearly dependent. So what we need to say, we need to say that vector C equals MA plus NB, and then equal I, J, and K components, and solve those simultaneously, if you remember how we do those questions. So let's see how the calculator will be helping us here. We'll say menu, algebra, and we'll solve system of linear equations. We have three equations and the pronumerals m, n, and I use L for lambda. So now I can say L is equal to negative m plus n. This is equating the I components. Negative 5 is equal to 2m minus 3n. This is equating j components, and negative 2 is equal to 2m plus n from k components, and we are after lambda, which is 17 on 8. So the answer to question 10 is B. We are approaching the time, so I might just talk you through a few other questions from the handout. So this is the parametric equations question. A particle is moving along a curve defined by the following parametric equations. So it is x in t is sec t, y in t is sine t, and we wish the equation of the tangent. So we'll use parametric mode. So graph entry, we need parametric. And if I open this screen here, sorry, I didn't change to parametric, menu, graph entry, parametric. And if I go up, I've entered sec t, sine t, and t is 0 to 14. Why is it helpful? Because what we can do now, we can find x1 in pi on 6, y1 in pi on 6, because we wish the equation of, to find the equation of the tangent at this point, and those variables already are predefined from our graph. So we find the point 2 root 3 on 3.5, and similarly we can find the derivative dx dt at this point and dy dt at this point, and using related rates, if we find the ratio dy dt over dx dt, we get dy dx. So our gradient is dy dx, and our point is 2 root 3 on 3.5. So if I enter that as a straight line, y minus a half gradient times x minus the point, and I expand and add a half, gives me the equation of the tangent. Therefore, answer to question 11 is B. Question 12 is our statics question. So we have 14 kilograms hanging in equilibrium, and we have 45, 45, so we have a 90 degrees here, and we wish to find the tension. I will use Lani's theorem. So if I have 14g down, we have three forces, so I can say 14g over sine of 90 degrees is t over sine of 135 degrees. So if I say solve 14g over sine 90, I'm in radians, but I force the calculator to use degrees because I put degrees sign. Is tension t over sine 135? The calculator returns t equals 7g square root 2, which is our answer to this question E. Couple more. Length of arc is our next question here. The length of arc from 0 to 4, arc 10x plus 1 correct to 3 decimal places. So I already done that too. So everyone would remember that if we go to calculus and we scroll Down we have arc length, and that's what we use. Enter the function 10 minus 1x plus 1 comma x and endpoints of the arc 0 to 4, and we get the answer 4.34. One more question. This question is on Euler's method. It tells you step size is 0.2. The differential equation is x minus y squared, and we start at x equal 1, and we want the estimated value of y to 5 decimal places when x equals 2. I'm using the graph screen actually. So if I change the graph entry to differential equation, I can enter y1 dash is x minus y1 squared, and this is my initial condition 1 and 0. So that's how we enter, and the calculator draws it. Important thing here is to press this button to edit parameters. Solution method is Euler. It comes by default. Do not change to the other one. And we need to change the step. The default step is always 0.1, but this time in the question it tells us the step is 0.2. So you need to change it to 0.2. It is under parameters. What I can do now, I can go menu trace, graph trace, and I need to start at x equal to 1. So that's where it is. And we need to get to x equal 2. So it will be 5 steps. 1, 2, 3, 4, 5. So when x equals 2, this is the value of y. This is, I think, much easier than trying to use your Euler's on the calculator, doing it graphically, as long as you remember to edit the parameters. So the answer is 1.10033, which is question 14 is D. And our last question for today is the dynamics question combined with vector calculus. We have position vector of mass 5 kilograms is given by this equation, and we wish to find the force in newtons acting on the mass when t is pi seconds. So what we can do, we can again tell the calculator the r in t is sine 2t cos t 5t cubed on 3. We are using the matrix entry here by using 1 row and 3 columns. And the calculator remembers that. Now we can find the second derivative at t equals pi, which gives us acceleration at time t equal to pi. So if this is the acceleration and we multiply it times mass, we get the force. So looking at our solutions, it's answer A for this question, 5j plus 50 pi k. So this is all we have for tonight. Thank you very much for listening. And we'll have the second part, extended response, in 2 weeks, and Stephen will be presenting this one.